What if the first Earthrise from lunar orbit was not a heroic astronaut snapshot, but the accidental result of a reconnaissance machine doing a dangerous job? That is the tension at the center of August 23, 1966. Lunar Orbiter 1 was not launched to make a poster. It was launched because NASA still did not have enough evidence to decide where people could land, what the ground might do to a spacecraft, or whether lunar photography from orbit could turn uncertainty into engineering judgment. The image that came back, Earth hanging beyond the moon, changed the emotional meaning of the mission precisely because the mission was so practical. The photograph was not the later Apollo 8 Earthrise, and it was not made by astronauts looking out a window. It came from a robotic spacecraft whose official job was severe rather than ceremonial. NASA had to reduce risk before it could risk a crew. Telescopes had made the moon familiar from Earth, but familiarity was not the same as landing knowledge. Engineers needed oblique views, crater shadows, slopes, planes, and repeatable measurements. They needed evidence that could be argued over in rooms full of maps, consoles, film strips, and worried people. In the mid-1960s, the moon was still being converted from symbol into worksite. Ranger probes had sent back close views before crashing. Surveyor landers were beginning to test whether machines could touch the surface softly. Lunar Orbiter added the missing orbital layer. It would circle the moon, photograph broad regions and detailed candidate landing sites, process film inside the spacecraft, scan that film, and radio the image data home. The system joined optics, chemistry, mechanics, radio, antennas, and human interpretation. If one part failed, a historic view could dissolve into noise. That technology sounds strange today because it was neither purely photographic nor purely digital. The spacecraft exposed film in lunar orbit. The film moved through a processor on board. A scanner translated the image into signals. Those signals crossed deep space and reached ground stations where engineers reconstructed the picture line by line. The famous Earth view was therefore not a simple click. It was a chain of decisions and fragile conversions. A camera with a job became a witness only because the whole chain held together. Lunar Orbiter 1 reached the moon in August 1966. Its planned work centered on Apollo landing site reconnaissance, but controllers also commanded a view that placed the moon in the foreground and Earth beyond the lunar horizon. The picture was grainy and banded. It did not have the clean emotional clarity of later Apollo photography. That imperfection is part of its historical value. It shows a civilization seeing itself from lunar orbit before human beings were there, through a machine built for risk reduction rather than wonder. Ground crews mattered as much as the spacecraft. Antennas listened for weak signals. Technicians watched meters and scopes. Image specialists assembled scan lines into something people could recognize. Analysts separated useful terrain records from images that could be shown to the public. The Deep Space Network was not background infrastructure, it was part of the photograph. Space history often remembers single objects, a rocket, a spacecraft, a picture. Lunar Orbiter 1 shows that the object worked only inside a system of people, tracking stations, procedures, and interpretation. Most lunar orbiter photographs were not famous icons. They were crater fields, mare plains, raking shadows, slopes, and details that helped planners compare possible landing areas. Those quieter frames made Apollo less blind. They did not make landing safe, but they made danger more specific. A smooth-looking plane could reveal hazards under different light. A crater rim could become a planning problem. A lunar surface that had once been distant and symbolic became a surveyed environment with choices, trade-offs, and consequences. The first Earth from lunar orbit photograph acquired meanings beyond the mission plan because it joined reconnaissance to perspective. Viewers could read it as Cold War proof, as technical achievement, or as an early environmental image. Earth looked finite because it was seen from somewhere else. Later Apollo crews would make sharper and more famous pictures, but Lunar Orbiter 1 arrived first from lunar orbit. Its emotional force came from the contrast between the small Earth in the frame and the practical machinery that produced it. That contrast also complicates the story. The image was beautiful, but beauty was not the reason the mission existed. NASA was mapping possible futures under pressure. Engineers were asking what evidence was enough, how much uncertainty remained, and how robotic knowledge could protect human crews who had not yet left Earth orbit. The photograph widened human imagination because a technical reconnaissance program did its work. It reminds us that exploration often changes culture through byproducts. A measurement, a test frame, a recovered signal, a picture made for one purpose that becomes remembered for another. The story also belongs to the people who had to trust imperfect evidence. A grainy strip of lunar terrain was not self-explanatory. Engineers had to decide whether a shadow marked a hazard, whether a smooth patch was really smooth enough, and whether a transmission artifact was being mistaken for surface truth. That is why the mission is more than a picture story. It is a story about institutional confidence, how NASA moved from observation to decision, from decision to landing strategy, and from landing strategy to the larger political promise that Apollo could actually be done. The first Earth view sharpened that confidence in a different way. It did not tell engineers where to land, but it told the public that lunar orbit was no longer an abstraction. The camera was somewhere else looking back. That fact made the rest of the program feel newly concrete. Before astronauts circled the moon, before television viewers watched a crew read from Genesis, a robotic spacecraft had already placed Earth inside a lunar frame. The image quietly prepared people for a scale of experience they had not yet lived. Seen from today, Lunar Orbiter 1 can disappear behind Apollo because Apollo gave the story faces and voices. But the hidden scaffolding matters. The spacecraft, the film processor, the scanner, the antennas, the consoles, and the analysts formed a bridge between a distant place and a human decision system. The mission's legacy is not only the photograph. It is the proof that a machine could scout another world in enough detail for people to follow. That proof made later drama possible. August 23rd matters because it marks the moment that utility opened into memory. Lunar Orbiter 1 helped turn the moon into a place planners could study, compare, and eventually approach. At the same time, it showed Earth as a small, bright world beyond another surface. The mission connected landing site evidence to wonder and survival planning to a new frame of reference. It showed that exploration is not only about reaching a destination. Sometimes the evidence gathered to make a journey possible changes how a civilization sees the place it started from. The mission's importance is easiest to miss when the picture is separated from the work around it. A viewer sees Earth and feels the shock of distance. A planner in 1966 saw something else at the same time, proof that the spacecraft could point, expose, process, scan, transmit, and be interpreted under real conditions. The photograph therefore carried two kinds of evidence. It proved that a camera had looked back from lunar orbit, and it proved that NASA's complicated reconnaissance system could deliver pictures trustworthy enough to affect decisions. That distinction mattered because Apollo was a chain of dependencies. A landing site was not chosen by courage alone. It had to be argued from images, shadows, slopes, radio knowledge, spacecraft performance, and the judgment of people who knew every image could mislead if read too quickly. Lunar Orbiter 1 entered that chain before the public had astronaut faces to attach to lunar orbit. It made a future crewed mission more concrete by giving engineers a surface they could inspect instead of imagine. The photograph also shows why robotic exploration changes human exploration. Machines go first not because they are less interesting, but because they can turn unknown places into questions people can answer. Ranger gave impact views. Surveyor tested soft landing. Lunar Orbiter watched from above. Each mission narrowed a different kind of ignorance. By August 1966, those machines were building a ladder of evidence, and the Earth-over-Moon frame became the most memorable rung on that ladder. There was also a public consequence. The Cold War space program was often described as a race, but this image did not look like a finish line. It looked quiet, remote, and fragile. It invited people to imagine Earth as an object in space before that idea became familiar through later Apollo photography. The image did not end political competition or technical danger, but it added a new emotional vocabulary to a program driven by deadlines, budgets, and risk charts. That is why the frame should not be mistaken for Apollo 8, for a moonwalk, or for a lander waiting on the surface. Its power came earlier. No one stood there. No boot prints crossed the foreground. The witness was a machine, and the human achievement was distributed across designers, launch crews, tracking stations, image specialists, and decision makers. The picture became iconic because their practical system worked well enough to create wonder by accident. So the legacy of Lunar Orbiter 1 is not only the first Earth photograph from lunar orbit. It is the older, harder lesson behind the image. Exploration advances when institutions learn how to convert danger into evidence without pretending uncertainty has vanished. NASA still had failures ahead, and Apollo still demanded extraordinary risk. But after August 23rd, lunar orbit was no longer only a destination on a chart. It was a place from which Earth had already been seen, measured through imperfect machinery, and returned to human memory.